In the last video, I introduced you to reinforcement learning. I promised in that video that I will now post videos that make a course on reinforcement learning for algorithmic trading. I also promised that I'll make the course as simple as possible so anybody can understand it. If you look at reinforcement learning books, a lot of mathematics is used and it's really daunting and you get discouraged. But I'll not use much mathematics, very simple things. Very simple things. A layman, a person who has got no mathematical background can also learn it. So before we start coding our trading strategy, we have to understand few concepts. The first concept that I want you to understand is the Markov Decision Process. Each reinforcement learning algorithm is a Markov decision process. A Markov decision process is a sequential decision process, means after each time step, in this case after each candle we are going to make the decision whether we are going to buy or sell, or we are not going to open a trade. So Markov decision process is a sequential decision making process. In our case, as we are developing a trading strategy, so at the close of each candlestick like this we are going to make a decision whether we have to buy, whether we have to sell, or whether we don't need to do anything. Markov decision process comprises following: environment, agent, state, policy, action, reward. So now let me explain each thing. Markov decision process comprises of the following things: environment. Environment is the whole environment where the agent is observing. So in our case, the environment will be the chart. This is the chart, this is the environment, and the reinforcement learning agent will be observing this environment, this chart. For us, chart is the environment, and each candlestick will be defined by a state S1. S1, let's say we start from this candlestick S1, the next candlestick will be S2, the next candlestick will be S3, next candlestick will be S4. So this is how we have to define the state. Environment is defined by its state. Each, in our case, we will at the close of each candlestick like this, we will define the state S1. Then at the close of this candlestick will be S2. So what to include in the state? Now this is something challenging because it is up to you what you include. But if you don't include useful things, then you will not get a good result from the trading strategy. This is what we will do. We will define the S1 state. Let's say we start from this candlestick. Body is one feature of the state. Upper wick is another feature, lower wick is another feature. Then we look whether this is an upside, this is a harami candle or an engulfing candle. I hope you know what is a harami candle. This is a harami candle. Harami candle is this is a harami candle when it is enclosed by the previous candle. Okay. It's also known as inside candle. This is the engulfing. This is also a harami candle. See, this candle is enclosed by the previous candle, right? So this is a harami candle. This is also known as an inside candle. Now, this is also a harami candle. Engulfing candle. Engulfing candle is when the new candle engulfs the previous candle. This is an engulfing candle, almost the engulfing candle. So you should not worry. In the next videos, when we start coding, we'll again discuss these things. So this is just to show you that we are building a feature set for the state. So this is the candle S1. We measure the body, we measure the upper wick, lower wick. Then we see where's the harami candle, engulfing candle. Then we look at the simple moving average. This is the 50 simple moving average in this case. Now we will include the slope at this point as the feature. So this all we build the state for the environment. Now I hope you understand that what is environment. Environment in our case, because we are building a trading strategy, is the chart, and a state is that each candle when it closes, then we include some variables that we call the feature. That is the state. In case of chess, the environment will be the chess board and each chess piece, just to make it clear to you. So at each step of the game, means after each move, the board of the chess piece positions will change and then the state will change. So I hope you understand this, that what is an environment. Now, agent is our that algorithm, reinforcement learning algorithm. It is constantly observing the environment. And as I've said, the environment consists of features that I've explained some of that features we are going to include when we build the trading strategy and code it. So at each close of the candle, the agent will decide, looking at the state of the environment, should it buy, should it sell, or should it just take no action, hold. Right? So now you understand what's an agent. Agent is the reinforcement learning algorithm that will constantly be observing the environment state. Now, I think now this is clear: environment, agent, state. Now let's move to policy. Policy is our trading strategy. Let's say we open the buy trade, then the stop loss will be at the low of the candle, and our take profit will be, let's say, like 100 pips, right? So this is our policy. Action is the actions that the agent can take. In our case, the agent can take three actions: buy, sell, and no action, means neither buy nor sell, not sell. So this is the action. So we, at each candle close of the candle, we will record the state S1. In this case, there is a one candle, so S1. In this case, S2, S3, and action A1, A2, A3, and reward R1, R2, R3, like this. Now, action here, let's say we buy it at the close of this candle, and put the stop loss at the low of this candle. So this is according to our policy. And then we wait for 100 pip profit. The action buy. As long as the stop loss is not hit, so our trade is buy open. So here, this is a bearish candle. There is no action because no stop loss has been hit. So, so no action. Here also no stop loss is there, no action, and so you see no stop loss is it. So after that there will be just no action. Reward. Reward is the how much we make profit. This is a very important variable for our reinforcement learning algorithm because we want to maximize our reward. Let's say we say that we need 100 pip profit. So at the close of this candle, we have opened the trade S1, A1, R1. Reward here is just 0. Here it's a bearish candle, reward will be negative R2. Here again it's a bullish candle, reward will be the open different open close, it will be positive. R4 positive, negative. So once we add up these rewards, we'll get the total number of pips. Step. Step is just one candle stick in our case. Episode. Episode is as long as we don't achieve our policy objective, which is in our case either the stop loss is hit or the reward is hit, right? So let's say if we had opened the trade over here and put the stop loss here on the very next candlestick, the stop loss would have been hit and we have been, so that would have been a one step episode. But in this case, this is not one step at episodes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 steps, and we measure the total pips that have been made. So an episode, we can limit the number of steps. For example, we can say the maximum steps allowed are 10. After that, that episode is over. So this is how we want to define the Markov decision process, and this is how we have to code it. It's a very simple model. Once we start coding, you will understand how simple it is. You just have to just know remember this these things. Markov decision process comprises of environment, agent, state, policy, action, reward, right? And state is S1 if you start from this candle, and A1 is the action at state 1, and R1 is a reward. This then next each candle is a step. So this is S2, A2, R2, and then this episode is as long as we don't achieve our reward or the stop loss is hit. This is the episode. I hope things are clear and you have understood the concepts.